Hello everyone, thanks for tuning in. I'm Sean Chen, Solution Engineer at Premio. Premio is a global solution provider dedicated in the engineering and development of computing technology from edge to the cloud. Premio is striving to provide innovative building blocks to enable customer success in both server and embedded application. For the focus of this presentation, we will be highlighting what the typical heterogeneous computing platforms for both typical server and embedded systems, and what Premio has done differently to help customers to achieve even better performance. So I would like to start with the statistic from Gartner. It says 75% of data will be processed outside the cloud by 2025. I believe this is a very important statistic because it really highlights the value where the data is currently processed and why it is becoming a massive shift out from the cloud to the edge by 2025. This drives a new level of business intelligence, delivering real-time insight that requires the need of implementing AI at the edge. In the past few decades, GPU, high-performance processing, and high-speed data storage have constantly improved to support machine learning and training at the data center that involves massive amount of computation and data storage. Inference on the edge is a major opportunity for a business to gain a competitive advantage and improve operational efficiencies. Examples of use case for edge computing include autonomous vehicles, natural language processing, and computer vision. Next slide, I'm going to show the key performance required at the edge. Here, you can see a slide from research conducted by Next Curve. They have defined a 5G autonomous edge as a convergence of cloud computing, 5G, and AI. I think it does a great job outlining the latency requirement for the edge devices and the need of AI capability to run the real-time analytic at the edge to deliver truly real-time digital services, experience, and business capabilities. And to achieve that kind of latency performance requires careful integration of fast network connectivity and computing power, where heterogeneous computing, which refers to system utilizing more than one kind of processor and core, comes into play, which typically comprise of CPU and GPU, which we will show you in the next couple of slides. Before that, I would like to first talk about what is rugged edge computing. At Premio, we define the rugged edge computing with four major principles. Number one, convergence of latest IoT technologies from compute, storage, connectivity, and system-level ruggedization for reliability in harsh mobile and remote environment. It's a decentralization away from cloud resources with more localized compute for machine learning and AI. It's a dedicated hardware and system-level engineering that balance power efficiency, ruggedization, connectivity, to process and store valuable data from IoT sensors and devices. And its solutions are made up of IoT gateways, industrial computers, rugged edge computers, and 5G access servers that sit in close proximity at the edge. So what is solution needed at the rugged edge? The number one is a need for more localized processing to facilitate hyper-automation and real-time insight, When you are able to move all this processing power too close to where the data being generated, this is where you're going to extract the value. By running inference locally, can give you a smarter automation and more accurate prediction real time from a lot of this localized hardware solution, such as factory automation, surveillance systems that can provide early prediction for certain preset condition about to happen. The number two is the need to support a software advancement with hardware strategies that combines the latest technologies. Software and hardware needs to be able to work together. Crucial balance between performance and power efficiency. And at the same time, you need to maintain optimal operating condition. The third one is the need for faster data center performance at the edge. When we say data center like performance, we are talking about specifically hardware where multiple computing cores are utilized. That's the aforementioned heterogeneous computing exactly represents. By having multiple computing cores, high-speed networking connectivity, and fast NVMe storage resources at the very edge, this resource can dramatically cut down on the transport latency to meet the ultra-low latency requirement for the edge devices. This consolidating all the three drivers, Premio presenting to the market with the solution what we call AI edge inference computers. The solution is hardened and ruggedized for mobile and remote edge compute at the edge. It provides real-time processing and valuable data storage for machine intelligence in the inference analysis. It is also a consolidation of the latest compute, storage, connectivity, and ruggedization technologies to deliver robust hardware performance at the edge. From the next couple of slides that we'll dive into the typical heterogeneous computing platform in server and embedded application. So from this slide, you can see it's a typical server configuration, and on the right, we have listed out some of the key elements when we design, when we configure this type of system. As you can see, on the typical server environment, dual socket processor is often utilized to fully utilize the core count that the modern CPU offered. So as you can see, the CPU core count can support up to 128. The AMD EPYC can support 64 per CPU, and typically it offers multiple high bandwidth expansion slot, and sometimes it will be 0x16, but depending on the application, it will be by 8 and by 16 combined. As for the power consumption, it's not uncommon. This type of machine will consume that much power. Because you can see it will be 2,000 watts plus, and with the redundant power supplies. And the remote management is achieved by the IPMI via BMC. And speaking of the memory capacity, you can support the massive 8 terabyte with the 32 slot. As far as the system cooling, usually multiple heavy-duty fans and exhaust fans will use together to mitigate the thermal challenges. And also, you have to constantly monitor all the thermal sensors inside of the chassis to make sure that there is no overheating risk. So this is a typical setup for the heterogeneous computing. As you can see, CPU can attach to a NVMe. You can support a GPU as well, but it's a lack of some flexibility to in terms of expansion and in terms of the diversity of the add-on car options. So next slide will show you list out some of the key requirements and the key design challenges. So requirements as number one is more and diverse add-on car options such as SmartNIC and the DPU data process units as heavily promoted by NVIDIA after they acquired Mellanox, FPGA, and GPU. Yeah, a typical requirement is to get all this add-on car option blended to push the system to its full potential. And number two is the fast and expandable storage with new NVMe technology. NVMe technology introduce low latency and very high throughput. And the third one is the remote access through NVMe over Fabric. Basically, what it does is enable a very low latency communication from the remote device to the local device. So it's with respect to the hardware perspective, you have to first have the NVMe storage, and the second is you need to have a spare PCI slot to support the RDMA NIC such that NVMe over Fabric can be implemented. The fourth one will be the hardware array option. So there are still applications that will house the sensitive data that require the redundancy here, so that there's still requirement for the hardware array option. And last but not least, the efficient and real-time enclosure management. Of course, you have to constantly monitor all the enclosure information to help you make a decision. For example, how fast the fan needs to be spun up or spun down. That's trying to reach a balance of power efficiency and performance without compromising on the overall operating condition. And let's move on to the design challenges. The first one is like, broadly speaking, the 2U chassis can only support a low-profile car. If you wanted to use a 4i car, you have to use a riser. And that's something that you have to think creatively, trying to create a riser without introducing thermal issues, such that you have to create a riser in a way that do not block the airflow, something like that. So the second one will be, the second challenge will be the traditional SAS SATA SSD cannot fully leverage the software advancement due to the legacy SCSI bottleneck. That's exactly why the NVMe has been introduced to specifically tailor for the flash-based SSD to reach the ultra low latency, really high throughput. That's something that the current computing world is supporting, just to push the full potential on the NVMe systems. And the third one is the latency introduced involving moving data via network and the CPU to run the bounce buffer. And that's the key reason why the NVMe over Fabric has been introduced. The next one will be the NVMe RAID require the PCI switches to support more than 8 SSD, and the typical NVMe RAID, we call it Tremor card, can support SAS SATA NVMe 3. So in the market, we call it Tremor card. And the Tremor card can support direct attach up to 8. So if you wanted to support more than 8, you have to add the PCI switches. And of course, the trade-off between the power efficiency and the target performance is the challenge across all the server and embedded application. Here, we just wanted to show you Premio's solution and how Premio responded to the previous mentioned challenges. From this bar diagram, as you can see, the PCIe switch has been implemented and bundle with the optimization of the chassis design, and also how we execute the enclosure management, trying to mitigate the thermal challenges. So with all this solution implemented, we come up with the next slide that will show you a system that after we implementing all the solutions, and this is the system that we came up. So this slide is to show, not to show, only to show you the exact system that been built up to address all the challenges. I will also list out the key solution that we implement to address the challenges. So we offer the riser options for high car of the piece of the CPU root complex, and also the option to utilize the PCIe path-through riser so that you can leverage the PCIe length of the switch. So if your application can benefiting from using the peer-to-peer communication that's ultra low latency, that will be really helpful. And we are Premio also adapting the MEME technology by leveraging the massive PCIe length offered by AMD, and we are adding this fan-out option for Intel using the PCI switch. Because AMD can support 128, and Intel, the most recent generation, can support 64. And we are also leveraging the latency peer-to-peer communication that is really promoting by the industry now. And of course, the mechanical engineering activities need to be considered in order to overcome and to mitigate the thermal challenge. So from this slide, as you can see, this is a 2U machine, and with it can support a 12 acceleration card in the front. And the uniqueness of this system not only is supporting two 96 lane PCI switches, it also support front accessible the carrier tray for acceleration card. And the even uniqueness of this car is that this system is that with only simply push a button that you can hot swap, hot remove the car without turning down the system. So this system just basically just showcasing how we implementing our solution to address the challenge that we have been facing. So let's move on to the next slide. So this slide just trying to briefly introduce some benefit of the PCI switches. And first one is enable the peer-to-peer communication between the PCIe devices. And the most notable implementation will be the GPU direct storage promoted by the and supported by the NVIDIA GPU. What it does is allow the GPU to access the data directly between the MEME and MEME over fabric technology to the GPU memory. So it's really cut down the latency required and in turn improve the performance. And more benefit including efficient host-to-host communication, flexible port configuration, multi-host configuration, and robust PCIe interconnect. It supports Spectrum clock isolation, and support SRIS, DPC hotplug, I/O sharing, enhanced enclosure management. All these features it's offered by the PCI switches. We're probably not going to use all of them, but it's really helpful in terms of supporting, for example, for the SRIS, that particular feature will allow you to remove the clock buffer from the backplane if your device supports SRIS. And on the now on the market, we test the Gen 4 drive we have tested so far support SRS. That will significantly lower the components used on the backplane, and in turn, that you can add more venting hole to improve the thermal and further mitigate the thermal challenges. So this is a type of benefiting an indirect benefit from using the PCI switches. So on the slide, there are a couple of examples. The right diagram shows the two hosts sharing a same PCIe network, and you can see blue and yellow hosts can share one SRLV device as long as they are in the same network. And on the right, you can see it's a single host, but actually it's by using the virtual switch features, you can using the two uplink to access two drive. So here we comes down to the start to look at the heterogeneous computing in a typical embedded system. So the notable distinction between the embedded application and the server system is, you can see the embedded system heavily relies on the PCH. Reason being that the PCH has the diverse I/O option. It can provide you diverse I/O. It's UART, a CAN bus, or digital I/O input/output. And also can provide you diverse dimension option through its PCIe lens. And we also list out some key elements on the right. The core count is up to A. The typical PCI GPU slots 1/16, and the typical usage will be for the video card. And the power consumption really depends on the application. And the memory can support usually 128. And the cooling, passive cooling is also preferred, and due to the nature of the embedded system, it's always require less power, and it's really that's the reason why the embedded system always put together with the fanless. That's the reason why the passive cooling is really preferred. But active cooling is not uncommon for the power-intensive application. Of course, you need to have the optimal fan control in place to mitigate the thermal challenge. Multiple displays, the CPU usually natively supporting multiple displays. The storage interface compared to the NVMe for the server, the SATA is still legacy interface for the embedded. Most of the embedded system starting to support the PCI interface, but it's still the PCI interface is off the PCH. So the performance is still gated by the DMI between the PCH and the CPU. So here, again, we are listing out some of the key requirements and the design challenges for the embedded application. For the requirements, number one is the balance in power and performance with multi-core processing. Either it's a system on chip SoC versus a socket design. Always is the balance that you need to carefully consider when looking at this requirement. And the second one is the I/O architecture direct access to the PCI interconnect. So the PCI interconnect is become a very basic interconnect interface for the computing devices. As you can see from the previous slide, the GPU, FPGA, all this acceleration or different computing processor cores, they're all PCI based. So it's really PCI interface is efficient and the speed is fast. Now the current generation is PCI Gen 4 and the PCI Gen 5 is going to be available next year. So it's really fast and reliable, and the whole ecosystem is there. The third one is the hardware security encryption, and this requirement usually can be accomplished by implementing the TPM module. And the design challenges is the performance limitation in the CPU and PCH combination. So the CPU is usually offering 1/16 typically, and the PCH will offer a more PCIe lanes for diverse I/O expansion, but still there is a limitation there. And the next one, the I/O bandwidth limited. It's all because of the specific type high-speed interface available is limited. So bandwidth, not only the option is limited, performance is limited, the I/O bandwidth is limited as well. And the PCI slot utilization is inefficient, so because the CPU usually can only bifurcate to 2x4. So if there is a device that does not require that many PCIe bandwidth, there will be a waste. So that's efficient PCIe slot utilization. And number 4 is the poor storage performance, because the legacy SATA still being used on the embedded system. Compared the bandwidth throughput and the latency is really not that great compared to the NVMe. Especially when NVMe attached directly to a CPU, the performance really got boosted. Here, from this diagram, you can also see PCIe switches being implemented to bifurcate the by16 from CPU to support a mix of GPU, TPU, and .2 accelerators and NVMe SSD. So this is our Premio solution to address the challenge that we are facing. So with this type of implementation, the NVMe SSD attached to the CPU directly for superior storage performance, a much lower latency and much higher throughput. Here are the solutions that Premio is bringing to the market. As you can see from the previous broad diagram, here is the actual product that we have engineered to offer to a market. So the RCO6140 GPU NVMe Premio, we call it the AI Edge Inference Computer. On the top module is our legacy RCO6100 fanless industrial computer. On the bottom module is our Edge Boost nodes for a variety option for a hardware acceleration, TPU, and .2 accelerator, and NVMe storage. What the most unique feature of this product is it offers you a lockable drive and hot swappable canister bricks that this hot swappable canister bricks allow you to mount this storage from the system without OS intervention. What does that mean is that you can simply push a button, and this button will provide the indication that the mounting is whether in process or is finished. So this can be accomplished by the API that Premio provide, so that your application can hook up with the API. So once this button is pressed, your application will know, and your application can start like dealing with the mounting and clearing the cache, some type of stuff. And once you feel comfortable about mounting the volume, that you can send a signal to this particular button to let the user know that you are free to go. So the user can unlock this canister, pull out the canister, and replace a new one with basically to refresh the capacity. So this would be beneficial in terms of portability, and also give you a way to move this canister to an offload machine, whether it will be a lab or whether it will be a a centralized location to offload the data. And some of the key other feature will be the wide temp, vibrating temperature support, industrial shock and vibrated, and last but not least is 5G ready. We have a proprietary dollar board can support up to two 5G SIM card, and we currently support USB interface, and but it can also support the PCIe interface as well. So this slide just give you an idea in the broad diagram form that how our Edge Boost node option provide. The first one, which we bifurcate 1x16 to by 8 plus 4x2. And the 1x8, we allocated by 8 to a full length GPU. So basically, it's a double width GPU, and we can support for a NVMe SSD with it. The NVMe SSD will be 7mm. And then the second option is we bifurcated it's by 8 by 2. Basically, it can support 8 7mm U.2 slot. Each one can support either one NVMe or one M.2 accelerator through our proprietary interposer. The third option will be bifurcating 1x16 to 4x4, and basically what it does is supporting 4 15mm slot. So it can support a 50mm drive, which typically higher capacity, and at the same time, this slot can support each slot can support 2 TPU or M.2 accelerator with the heatsink on the top of it. So that's for more power hungry M.2 accelerator. You can support that as well. And the beauty of the design is that if you have custom requirement, you want to support mix and match, we can support that as well. So basically, this concludes my presentation today. And in summary, I would like to thank you for listening to our presentation. If you would like to learn more about our rugged edge computing or Premio itself, you can visit online at Premio. Thank you and have a good day.